All right, welcome to the Unit 2 review. Remember, test tomorrow. So this is going through that. And here we go. Number 1. So we have AC congruent to BD. And remember, we can really think of AC as these two segments, AB and BC. So really we know that AB, right? That's a terrible B. Let's try this again. That AB plus BC is equal to, and on the other side, we have this segment underneath, right? We have BD, which is actually a combination of, right, BC and CD, okay? And so in the middle, right, we can see that they're sharing this segment BC, and if we were to subtract that from both sides, we get left with AB equaling CD. And so the answer is choice number 1. All right, for number 2, given the information here, which of these statements is true? You want to justify your answer. Justify just means show your work. So if these two angles were equal, or if these lines were equal, right? If these lines N and P were parallel, then these two angles should be equal. So this should be 122. The question is, does 122 and 68 equal 180, right? And if it does, then we know they're parallel. But 122 plus 68 is 10, right? That's 190. So we know these are not parallel. So it's not N and P. Okay. Then we can look at the next one and say, well, look at L and N. If these two were equal, these would be alternate interior angles. They should be equal. They're not. That's out. What about L and P? So same thing. This should be 112 because these are corresponding. And so it's 112 plus 68 equal to 180, right? And it is. So those lines are parallel. So that would be the answer. If we look at M and P, right, you can see this angle, the 68, should be the same as this angle. And then these angles should be equal, but they're not. So that's out. And then we look at the next one, okay, M and N, same concept, right? These two angles should be equal. So this should be 78. And then together, these should give you 180, right? And that's too much. This is actually 200, so not going to work, all right? Number 3, which is actually the same as 11. So we're just going to solve for it in a way. We know the answer should be 16, but we're going to do it anyway. So 5x minus 22 is angle TVQ, which is this guy, and VWS is this guy. So these are equal. All right. And then we're just going to solve for x. We can subtract 3x from both sides. Okay. We can also add 22 at the same time. All right. And we're going to get 2x is equal to 32. And then divide by 2. And that's where x is going to equal 16. Just double check. They're not looking for just x, whether or not you're looking for x or the angle. Okay. In the diagram below, angle BDC is 100. Angle A is 50. And angle BDBC is angle up here is 30. All right, which statement is true? So we want to figure out all the other angle measures, really. That's going to be key. So if this is 100, the angle next door to this is 80. Okay. And then we can do like 80 plus 50 is 130. And 180 minus 130 is 50. So this angle is also 50, which makes these two angles congruent. If this is 130, that's 130, right? Which makes this 50. Okay. And so like we can tell two things. Number one, we can tell that this triangle ABD is isosceles. Okay. Those are E's. Because we have two base angles that are equal. And we can also tell that this triangle all the way around, okay, is also isosceles because it has two base angles that are equal, okay? So we see ABC is isosceles, ABD is obtuse, which is false, it should be an angle more than 90. All right, ABD is 80, okay, which is not as 50, and ABD is scalene, which it's not because it has two angles congruent, so it's got to be choice 2. All right, in the diagram below, angle 1 is actually 63, so we'll label that in the diagram. We know the lines are parallel and that there's a right angle here. So remember, we're looking for the Z. So this angle is 63, and then we're looking for angle 2. And since this is a triangle here, we know that these three angles are going to add to 180. So 63 plus 90, okay, is 153, and then 180 minus that. Also, the thing you can think about here is that if there's a right angle here, that these two angles have to be complementary. They have to add to 90. So I can just do 90 minus 63 here and get the same thing. All right, and that's the measure of angle 2. On to the next one, number 6, ABE. ABE is 52 degrees. Figure out the measure of angle D up here. Same kind of approach here. Now we also know that EBD, this angle, is equal to CBD, this angle. So you can think about it in terms of like if these are both x, that these three angles right here are going to form the straight line, and so they all have to add to 180. So we can do that this way, and that keep in mind that that has to be right angle, okay? And we can also figure out that this is going to be 38 because these two angles have to add to 90. So we can do all those things. So if we just do like 2x plus 52 is equal to 180. Right, we subtract 52, get 128. And then we get 64. All right, so now that we know that this is 64, we can see that we have a right triangle here with 64. So these angles have to add 180, or the angle we're missing, D, right, has to add with 64 to give you 90. And so this is going to be 26 degrees. All right. Given, we want to prove. So this is a proof again. So we're going to do our solution on the side. Okay. So we know that these angles are vertical and equal. So we're going to do 4x minus 50 equals x plus 50. Subtract x from both sides. So 3x, right, minus 50 equals 50. Oh, no wonders. It's 4x minus 40, people. And that's too big. All right, so 4x minus 40. There we go. So and then we can add the 40 to both sides. All right, and you get that 3x is equal to 90, and then divide by 3 and get x is equal to 30. And we're just going to put the equations in our proof. So we're going to start with our givens. That's a terrible t-chart. Terrible. All right. So let's go back where we were. All right. So I'm going to do the t-chart, statements and reasons. You guys do it, and I'll see you back here. Okay. So we got the statements and reasons. We got the givens. Okay. So remember, we were able to create this first equation here, 4x plus minus 40 equals 50, x plus 50, because we said these are vertical angles. So we're going to go ahead and do vertical angles are equal here, okay? As our statement is the equation, and then the reason, all right? And then we got to the next equation, which is 3x minus 40 equals 50. And to get there, we subtracted x from both sides. So remember, that is the subtraction property of equality. Then we added 40 to both sides, so it should be 3x equals 90. That's the addition property of equality. And then we just divided both sides by 3 here, so that would be the division property of equality. And then that would finish off the proof. That's what that one should look like. All right. Okay, I'll leave it kind of here so you can see both. You need to copy down. In the diagram below of triangle JEA, right? That's 90 degrees. EAJ is 48. Line MS connects points M and S on the triangle such that this is 59. Find the measure of angle JSM. So we have to use, we're trying to find the measure of this angle right here. Okay, we have to use the fact that we have a few different triangles here, right? We have the really big triangle all the way around. And we also have this smaller triangle that JSM is part of, which is right here. All right. So what are some things we notice? Number one, we got a line going on here. So if this is 59, remember the angle next door to it is 180 minus 59. Okay, so that would be 121. All right. And then in the really big triangle, I have measures of, right, 90 and 48. So this is 138 between these two. So this angle up top here is 180 minus 138, which is equal to 42. And now I use the blue triangle to figure out that these three angles add to 180. So 121 plus 42 is equal to 163. And 163 taken away from 180 is 17 degrees. So angle JSM, that measure, is equal to 17. All right, number 9, the triangles are given below. Now the important thing here is this part. M and O are bisected by MS and OR respectively. So that means this original angle here is actually being cut into two congruent angles. All right, and the same thing with angle O up here. This angle is being cut into those two congruent angles. So once I know that N is 40 and TMR is 28, I now know that this top angle is 28 and that this entire angle measures 56 degrees. So in my really big triangle, right, that's going around the whole thing here, I have measures of 40 and 56, which is 96. So this angle O, right, MON, is 180 minus 96, which is 84. So each of these angles has to be 42. That's half of 84. All right. I'm just going to fix the 42 there. 42. All right. And then we're trying to figure out, right, OTS, this angle right here. Okay. There's another triangle right here. See it? And I have angles 28 and 40. So these two angles add to 68. So this guy is 180 minus 68, which is 112. So now I can get the angle next door to that one. All right. So 180 minus 112, right, is 68. So that's the measure of this angle. And now I have this inner triangle right here with angles of 42 and 68. So 42 plus 68 is 110. And so 180 minus 110 is 70. So the measure of angle OTS is also 70. Kind of a crazy question, but there's a lot going on there, but that's the main thing. Use those angle bisectors and then the angles in the triangle there. Okay, we're not doing number 10, so you can cross this one out. All right, we're going to jump down to number 11. So for 11, 12, and 14, I'm going to do the statements and reasons real quick. So do those, and I'll meet you right back here. Oh, by the way, number 11, it's a proof again. We already did the solution. So if we go back to the front page there, all right, and look at this guy. We're going to grab this and bring it back over here. You can go reference this solution in your proof. All right, so we're going to use this in our proof. So let's turn it to a color. Let's go blue. All right. And we're only going to do the equations as our statements, remember? So I'm going to go ahead and use this as my equation. That's my equation. That's my equation. All right. So I'm going to do the T-chart, statements and reasons. Go ahead and do that as well. All right. So our first equation, remember, was what we wrote down. That was the 5x minus 22 is equal to 3x plus 10. So we need a reason for that, and we kind of went over this in class, but in case we didn't, remember those two angles, TVQ, right, which is right here, okay, and VWS, which is down here. These two angles are equal because they are corresponding, right? So we're going to put down for ourselves, you got to remember, we got to start it with two parallel lines cut by a transversal, and then we can fill in from there. All right, the vocab word here is corresponding. Are equal. Then for step 3, right, we came up with the equation, and you may have done this in 2 steps. We did it in 1. We got 2x is equal to 32. Okay, if you got something like 2x minus 22 is equal to 10, that's fine too. We're just going to do the subtraction or addition, a property of equality, depending on what you did. All right. And it doesn't really matter which one you use, because technically you could say I added a negative or subtracted a negative to get a positive. And then the last step should be x is equal to 16, because that was the proof statement. And this one is going to be the division property of equality. All right. All right, on to number 12. So for number 12, we did this one in class already, but we'll roll through it in case you wanted to see it again. So in the proof statement, we want to remember that angle EBA, right, is actually a combination of angle 2 plus angle 3. And CBD is actually a combination of angle 1 plus angle 2. So really what we need to do is get these two angles, these two sets of sums equal to each other, and then we can swap out what we need here. So, all right, so we're going to do this first. Okay, go to yours. All right, so we got the givens. So what we really want to do here is we want to say that we want to add angle 2 to both sides. That's what's the different about the proof statement we wrote right here, right? This is 1 plus 2, and this is 3 plus 2. So technically what we should say is angle 2 is equal to angle 2. That's reflexive. Okay? And then we can go ahead and say angle 1 plus angle 2 is equal to angle 3 plus angle 2, which would just be adding 2 to both sides. So that is the addition property of equality. And then we're going to basically swap out 1 plus 2 for angle CBD, and we're going to swap out 2 plus 3 for angle EBA. And that's our proof statement. So we are good to go. And this is the angle addition property. If you wanted to do something like on an extra step here and say angle 1 plus angle 2, okay, is equal to CBD, and angle 3 plus angle 4 is actually equal to EBA, That would be angle addition, and then your last step here would actually be substitution. So if you do that step, that's fine. Just understand what you would say for each step there. All right, same thing for this one. Okay, so we're starting with the lines parallel. We want to get 1 plus 3 equals 180. So the real key link here is that 1 is congruent to 2, and 2 and 3 add to 180. So we can just make the jump that 1 and 3 should add to 180. So we're going to go ahead and say angle 1 plus or is equal to angle 2. Okay, then we want to make the jump here that for 3, that angle 2 plus angle 3 is equal to 180. And then we want to make the jump again to swap out 2 for 1 and say angle 1 plus angle 3 is equal to 180. All right, so that first one, that first reason there, okay, is that two parallel line statement. And then we're checking to see how they're related. In this case, the angles are corresponding. All right. For 3, we want to make those a linear pair. So we can say either angles that form a line are supplementary or add to 180. Or we can say linear pair angles add to 180 as well. And then for 4, we're just doing substitution because we're taking something out, putting something in. All right. And the last one, let's go ahead and do this one. Okay, so our givens, we know 4 and 3 are equal. Okay, so we can mark that for ourselves here. All right. And the other thing we know is that these two lines are parallel. So we want to get 4 congruent to 2. All right, so we want to use 3 as that jump off here. So if 4 and 3 are equal, we can show that 3 and 2 are equal because they're corresponding, and then we can just swap out. If you want to bring in 1 because they're alternate interior and vertical, you can also do that. But we're going to try to keep it short here. So we're going to say angle 4 is equal to angle 2. And that's our corresponding angles. So once again, we're going to do 2 parallel lines cut by transversal. Corresponding angles are equal. All right, then we're going to swap out because 4 is equal to 3, 2 is equal to 3. Actually, it's not 4 and 2, I apologize. It's 3 and 2. So 4 is equal to 3, and 3 is equal to 2. Then we can make the jump and say that angle 4 is equal to angle 2, which is the proof statement, so we're done. And the reason for this would be the transitive property. Or substitution, your choice. All right, guys, that's it for review. Let me know if you did anything else. See you tomorrow.